Hi, this is Sung, your online maths mentor, and we've been going through parametric equations, okay, which is an extension 1 topic for the HSC. And let me just go through with you a quick summary of what we've done. We recall that parametric equations can be expressed as two equations where you got two variables that are kind of related to a third variable, an in-between variable that allows us then to express that. So for example, on a parabola, you've got x and y, which are your two variables that make up the parabola, and they're basically expressed as two separate equations, both related to a third variable, which is t. Can be p or can be whatever letter you choose, but if it's t and x is equal to 2at and y is equal to at squared, then any point on that locus, on that moving path, will be given by that point t being 2at, at squared, the x and the y coordinate of that point as it moves along the locus of a parabola, okay? And then we also worked out the tangent of a parabola and the normal of a parabola, the equation of those based on the parametric equations of the parabola, okay? So we worked out that, you know, the tangent, which is this one here, I keep pointing to the normal, but the tangent will simply be a straight line that can be found using the point gradient form, which is y minus y1 equals to m outside of x minus m1, m in brackets x minus x1, where your x1 and y1 are 2at and at squared, and m itself is your first derivative of the parabola at the point of contact, which is t, right? And the way you find that is by using you know, a variation of the chain rule. Or it's not really a variation, it is the chain rule, okay? Which is dy dx, which is equal to dy over dt times dt over dx, or dy over dt divided by dx over dt, okay? Cool, and we basically worked that out, right? So that is basically what we did on parametric equations in a nutshell. And this episode, really, it's a long-winded way of launching into this episode, which is just about doing an example of a typical question you might find in an exam. So let's have a look at it. We've got example 1, the tangents at the point P, which are governed by 2ap, ap squared, and Q, which is governed by 2aq, aq squared on a parabola, x squared equals to 4ay, meet at a third point T, and a fourth point M is the midpoint of P and Q. And then part 1 says, show that the equation of the tangent P is equal to that. Well, we did that in the last episode. Let me quickly just run through it with you. We're basically using, okay, I'm using a black pen here. We're basically using the point gradient form, which is y minus y1 is equal to m x minus x1, yeah? And m, which is your dy dx, which is your first derivative, is going to be equal to t. Well, in this case, it's going to be equal to p, right? Okay, so it's going to be equal to p. Your x1 is going to be equal to 2ap. Your y1 is going to be equal to ap squared. Okay, and then it's just a matter of substituting into the formula. So it's y minus ap squared equals to p outside of x minus 2ap. You simplify that, bring the ap squared over to the other side, and that basically is how you do part 1. Okay, so we kind of did that in the last episode, but I just thought I'd do it again because it's required for us to do in this particular question. All right, so that's part A. Let's do part B. It says find the coordinates of t. Now, if the tangent at P is equal to y is equal to px minus ap squared, what do you think the coordinates at, what do you think the equation of the tangent at Q is going to be? Well, it'll be exactly the same, but instead of p's, you'll have q's, right? So qx minus a q squared, right? So basically we need to mind our p's and q's. We subtract one from the other and we should get, or we can equate the two, because basically the solution to point T, right, the coordinates of point T would be the solution of this simultaneous equation, because you've got one tangent going this way, another tangent going this way. Where they intersect is going to be there, the coordinates of point T, right? So the point T, right, is going to be the solution to that simultaneous equation, right? So solution to simultaneous equation will be T, okay? All right, so the point T. So let's work this out. So we've got px minus ap squared is equal to qx minus aq squared, right? So basically what I've done is take equation 1, take equation 2 and equated them together, okay? So this is equal to that because they're both equal to y, all right? Solve that, you've got p minus qx is equal to ap squared minus aq squared, right? I've taken this bit here, brought it to the other side, okay? And that minus becomes plus. You can probably see here that it's the difference of two squares. All right, you can factorize the a out first and then it's the difference of two squares. So it's p minus q, x equals to a outside of p squared minus q squared. X is equal to a outside of p plus q, p minus q, all on p minus q. That cancels with that. X is equal to a outside of a p plus q. Right, and now we just need to work out what y is equal to, yeah? Now to work out y, substitute x back into the equation of the formula, and that'll give you your y coordinate. So let's do that. So y is going to be equal to ap squared plus apq, right, minus ap squared. Okay, so basically I've taken this, expanded it out, multiplied by the p, and that gives us this bit here, and then minus ap squared, which is that. So I've substituted back into x back into equation 1. All right, sub into 1, and that's what I've got. Okay, so y is basically going to be equal to apq. So t is equal to, what is it equal to? A p plus q and a p q. Got it? So that's what t is equal to. Now, the next thing, so we've done part B. So that's part B. Part C, prove that MT is parallel to y. So what we're going to do now, let me just rule this off. What we're going to do now is we're going to work out the coordinates of M. All right? So M is equal to that plus that over 2, 2AP plus 2AQ over 2, and it's also equal to AP squared plus APQ squared, AQ squared on 2. All right, so we've used the midpoint formula to do that. So basically the sum of the x coordinates divided by 2, the sum of the y coordinates divided by 2. Does that make sense? So M is equal to 2a outside of p plus q on 2, a on 2 outside of p squared plus q squared. Got it? Now these two can cancel, so M is basically equal to a p plus q and a on 2 p squared plus q squared. They're your coordinates of M. All right, so now it says prove that MT is parallel to the y-axis. All right, so what we're going to do is use the gradient formula. So M of MT is equal to essentially y2 minus y1 over x2 minus x1. All right, cool. Now, what we can do is basically use the x coordinate of M as y2. So it's M, the y coordinate of M minus the y coordinate of t over the y coordinate, over the x coordinate of m minus the x coordinate of t. Does that make sense? Okay, now the y coordinate of m is this one here, a on 2 p squared plus q squared minus, now the y coordinate of t, which is apq. Now this isn't looking pretty, the top isn't looking pretty, but I want you to notice this. The bottom is looking very pretty, okay? The bottom is looking very pretty because what you have is a outside of p plus q minus a outside of p plus q. So it's a outside of p plus q minus a outside of p plus q. Now, if you've got one thing minus the same thing, what does that give you? It gives you 0, right? So this ends up being equal to 0. But what can you tell me about a gradient where the denominator is 0? Okay, basically it says that the gradient is undefined. All right. What is an undefined gradient? Or what is a gradient where the denominator tries to equal 0? Well, it's basically a vertical line. Does that make sense? It's an undefined gradient. So what it is a vertical line, which means it is parallel to the y-axis, because the y-axis is a vertical line as well. Okay, so therefore, and this is part C, therefore MT is parallel to y-axis. Got it? Beautiful. All right, so it is parallel to the y-axis. All right. The next question we're going to do is to find the coordinates of the midpoint R between M and T. All right. Now this will be slightly a little bit more difficult. Okay. It will require us to basically find the average of that and that. Okay. So let's do that now. Okay. And what we'll do is we'll rub this out and I'll do it again. Okay. So let's do part D. The coordinates of M are and the coordinates of T are. All right. So here's what I want you to do. R is the midpoint, right? So R is the midpoint. The x coordinates of R are going to be A outside of P plus Q plus A outside of P plus Q all on 2, right? Which will just be A outside of P plus Q. Because if you add this with itself, you're basically doubling it and then you're halving it, which leaves you with the same thing, yeah? So the x coordinates of R is that. Now, let's have a look at what the y coordinates of R do. The y coordinates of R are A outside of 2 P squared plus Q squared plus the y coordinates of T, which is A, P, Q, and all of that over 2 will give you the y coordinates of R, which is the midpoint, right? Now, here's what I want you to notice. I'm going to take out the half A. Let's take out half A over 2, and you're left with P squared on this side, you're left with Q squared on this side, which is basically this Q squared over here. And if you take out A here and a half there, you're left with adding 2 lots of PQ there. Does that make sense? All right, so see if that does make sense. What you will notice, and why I've done this, is because all of a sudden this becomes a perfect square. Do you see how this is a perfect square now? And so you're left with A on 2 outside of P plus Q all squared on 2. Now this 2 and this 2 can multiply, and you're left with A outside of P plus Q squared all on 4. Okay, so what is the coordinates of R? All right, the coordinates of the midpoint R are going to be A outside of P plus Q and A on 4 outside of P plus Q squared. Got that? Cool. And then the last one says find the equation of the locus of r. All right, so I'm going to rub this bit out and do the rest of that here. Now, if your x coordinate equals to a outside of p plus q, then p plus q is going to be equal to x on a. Does that make sense? That's going to be very important because we're going to substitute that into your y. So y is equal to a on 4 p plus q squared. But we know that p plus q is equal to x on a. Therefore, y is equal to a on 4 times x on 4 squared. Yep. And we just need to simplify that down. Okay, so y is equal to a on 4 outside of x squared on 16. Y is equal to a x squared on 64. So that leaves us with 64y equals to ax squared. Right? Again, if you simplify that down, what you'll get is another parabola. All right, so you've got x squared equals to 64 on a y. Okay, and that's your answer to part E. All right, so that's basically how you work with parametric equations on the parabola. You basically just use the parameters like they are normal points, algebraic expressions to represent a point, and you just work it out like that. It will require you to use a bit of practice and do a little bit of practice, but re-watch that episode if you need to, and I will do one more example on the next episode. Thank you very much for watching.